Welcome to Smart Architectural Programming. Today, we're diving into an exciting topic, Python expressions.
If you go to the coded examples for this, simply put, if you want to check a membership in the list, what it means that we need to check if a certain word or value is present in the list. So a list has a list of multiple strings or values within that. By value, I mean a string or a numeric data type, any sort of data type that's saved within a list. It can be more than one. It's usually more than one. That's why we create lists. So here you can see in line 2, we create a list called fruits. And within the list, we have 3 items, apple, banana, and cherry. Look at line 2, you'll see that. On example number 10, membership in a list. In line 3, you'll see a variable called result. So in this variable, we are asking to see if the word or the item banana is within the list. So we use banana in fruits. That is the name of the list. We're using in-word to check whether that specific expression we have a value called banana is in the fruits list. As this value is there in the fruits list, item number 1, basically we're indexing from 0, so it's item number 1. Again, keep that in mind. In computing, counting doesn't start from 1, it starts from 0. So you need to completely reprogram how you count in your head when you're dealing with programming. So apple is item number 0, banana is item number 1, and cherry is item number 2. If you're counting normally, apple would be 1, banana would be 2, and cherry would be 3. But again, in computing, banana is index number 1 or item number 1 in the list. So it checks, it finds banana as item number 1, and it saves the result true within the result, and the output is true. In example 11, we check membership in a string. So it's the same, exactly the same thing that we did. Instead, in a string, there are multiple words in a string, more than one word in a string. So we can test if a word is there. Again, this is case sensitive. If both of these are case sensitive. So if you checked for with banana with a capital B, the answer would be false. Similarly, if like in example number 11, if instead of searching world with lowercase w and the entire lowercase world, I added any single capital letter within that, the answer would have been false. But since it's the exact replica of what is in the text of the string, we output true. So membership is just checking if a certain word case sensitively is present within an item or a string or a tuple or a list, whatever we're talking about in that particular case. Here we just went over examples of strings and list. So again, for tuples, it's the same thing. So again, you can just extend this understanding of this knowledge to tuples as well. Now we're moving on to the last item of the video, and the last item that we're going to discuss in chapter 3 and wrap up the videos of chapter number 3 and wrap up your learning of chapter number 3. So these are identity expressions. Please check whether if 2 variables point to the same object or not. Now, this is going to be a little bit tricky because this refers to memory positioning to a large degree. I wouldn't go too deep into that. I'll just go over it briefly. This is something that you might not touch a lot in Python because Python is an advanced language and it has a lot of abstraction features. These are the sort of things that you'll usually deal in lower level languages like C, so on and so forth. So here we need to check whether if we create 2 variables point to the same object. In this case, we have, if you look at the last part of the video, example number 12 is checking whether is we check whether a variable A and B point to the same memory location, and that's what you can abstract this to. It's usually in Python we refer to memory locations as objects, but here you can refer this as objects instead. So A, we create a list in line 2 called with values 1, 2, and 3 within that list, and we create a variable B where we equate the value of variable B to A. So Python has instead told we've told Python that you don't need to create a new variable spacing. Just tell that B is moving towards A. Let me put it this way. So let me see. Give me a second. Let me pull up a quick application for a marker, and let me explain that using that. You can open a whiteboard here and quickly explain what I mean by pointing to a specific object within Python. So let's give it a second. Let the whiteboard open. So we have a variable called a, right? And a has a certain value associated with this, as you can see in the screen. Let's say it's an empty list here, right? Right now we have a list that does have values, but we're just gonna assume that it's an empty list. So when we tell b is equals to a, what Python understands is that instead of creating a new space within the memory, for example, if we have this is a memory here, just understand that this memory here has certain the space within that memory is divided into different chunks. So if the memory is divided like this, and every chunk has some point of data that we save using programming. So if the memory of if the value of a is stored in, let's say, this this memory block, and usually when a new variable is created, it would randomly find another space. So it won't just create a value right next to it, a here. It might just create save the value of b here if a new variable called b is created with the value. But that is not the case. Instead, the value we're telling Python is that the b's value is what is a's value. So as modern languages evolved, there's a little more intelligence that goes with the computer. So instead of creating and wasting more memory by just replicating what is the value of a and created a new memory space with that value and associated with the variable b, what Python tells simply is the value of b is just simply pointed towards a's memory block. So if b is equals to a, just points to the memory location where value a is saved, and that is basically it. That's what we mean by pointing objects, pointing objects to, pointing towards objects within Python, and within this these expressions called identity expressions. So these two variables point to the same object or the same memory location. So here the b variable is pointing to the memory location of 1, 2, and 3. And just to check if an object or variable is pointing to the same location as another object, we use the keyword is. As you can see in line 4, there's a variable called result where we say a is b. So between two variables, we write is to check whether both objects are pointing to the same direction, particularly if the value of a is being pointed towards by the value of b here. That the result is true because that is the case. Another thing is just using doing the opposite of this, is using the is not. Here, as you see, we didn't point a to b. What we're doing is inefficiently creating a new variable, creating a new memory space where we're creating b with the same exact values as a. But it's not, b is not being pointed towards a, as we discussed earlier. So what happens in this case is that they are not pointing to the same object, hence they are not, identical. So in this case, when we can use an expression to check if two variables are not, pointing to the same memory location, that is not, just like we did in line 4. You can look at line 10. We use the not expression with the is expression, or the is not expression between two variables that we want to check if they're not identical to check, and that's true. So the answer is true, as you can see on line 11. With that, we would wrap up our video on third video on chapter 3. And also all of our content in chapter 3 has now been covered. I would like you to go back to the book, read it one more time, develop a deeper understanding of the things that we went over, explore a little bit on the internet, look around for things that you might seem be unfamiliar with. You can check out our YouTube channel, Smart Architectural Programming, as well. And with that, chapter 3 is a wrap, and we'll see you on the next videos. Thank you.